Good morning. Today is e-learning day, March 17th. I'm going to continue on with the notes from yesterday. So here you have already a completed version of where we left off yesterday, trying to find the nth term for each of these last two patterns. So as we were talking about yesterday, right, this -1 to the n plus 1 power, that's going to allow us to have this alternating signs from positive to negative, right? And then we see that as we go from one term to the next, everything is doubling. It's doubling the term number. Again, n represents the term number. So you see when you plug in 1 in for n, you get 1 plus 1 is 2. -1 to an even power makes it positive. And we have our positive sign, 2 times 1, because again, n is the term number. So plug 1 in for n. 2 times 1 is 2. And then 2 times the positive 1 is 2. Plug 2 in for n. 2 plus 1 is 3. Put -1 to an odd power. That makes it negative. Right? 2 times the term number of 2. 2 times 2 is 4. 4 times -1, -4. This one's kind of an odd sequence, right, where it kind of changes from a whole number to a fraction. So this one's pretty complicated, so you can look at this and test it out to see how this all works. Okay. So here's the definition of what an alternating sequence is. That's what these last two are. They kind of alternate from either signs or different number types. All these sequences have been explicit sequences. So the word explicit, with the formula for the nth term, it is convenient to find any term in the sequence. Again, an explicit sequence is one where you can just simply plug in the term number in for n, and then you can get what you're looking for in terms of the term value right away. There's also something called the recursive. If you guys remember this from Math 1. You can define a sequence recursively. In a recursive sequence, each term involves one or more terms before it. So again, the review from Math 1, right, in a recursive sequence, you have to be given some term value. So here we're given the first term is 1. And then you have an expression that says, okay, if you want to find the current term, you are going to take the previous term, right, and for this one, you're going to subtract it from n, which is the term number. So again, if you plug 1 in for n, so you're looking for the first term. Let's say, let me take that back. Here I made a table where the first term is 1. So again, we're given that. All right, to find the second term, according to this formula, you're going to plug 2 in for n. All right, so I want to find the second term. I'm going to plug 2 in for n, and then this next part says, okay, so from there, 2 minus 1 is 1, so to find the second term, we're going to take 2 minus whatever the first term is, and the first term has a value of 1, so that's why I have here in my table, the second term is 1. If I want to find the third term, plug 3 in for n. So to find the third term, we're going to take 3 minus the second term. So third term is 3 minus the second term. The second term was 1. So here I have my third term is 2. Okay, so we continue that pattern to find, right, these 5 terms. Says here, write a recursive definition for the sequence. So again, if you're given a sequence like this, and you're looking for a pattern, you notice that to get from the first term to the second term to the third term and so on, we need to add 5. So here is a recursive where you have given that the first term is -3. And to find any term after that, you're going to find the nth term by taking the previous term and then adding 5 to it. Okay, so here, if you remember from Honors Math 1, this is the common difference. Okay, so we're going to skip this Fibonacci sequence right here. Move on to the next sheet. Alright, so can review arithmetic sequences from Honors Math 1. Alright, so again, this is arithmetic because there is a common difference that exists between the two. Alright, to go from one number to the next, we see the pattern is we have to add 7 every time. Alright, this is not arithmetic because as you go from one number to the next, right, the value changes, right? Go from 4 to 5, 5 to 8, 8 to 10. Right, there's not this constant difference or common difference between the numbers. So this is not arithmetic. Because this should go by pretty quickly again because this is something that you did in Honors Math 1. So let's just a little bit of a review. So here we're given this sequence. A sub 1 meaning what's the first term. First term is 4. D representing the common difference. We see as you go from one number to the next, you got to add 3. For this sequence, the first term is 5. As you go from the first to the second to the third to the fourth and so on, we see that you have to subtract 4. So the common difference here is negative 4. Alright, so here again we can show you how you can use the definition of a sequence to find the terms. So again, you simply plug in the term number in for n. So that's what I did here. I plugged 1 in for n, did the math, and I got the first term is 2. Looking for the second term, I'm going to plug 2 in for n, do the math, I get 0. To find the third term, to get negative 2, I plugged 3 in for n, again 3 representing the term number, 3 in for n, did the math, and I got negative 2, and so on. Okay, so once I found all 5 terms, I'm looking at as I go from one number to the next, and I see yes, it's changing by a common difference. You got to subtract 2 each time, so that means it is arithmetic. Okay. All right, so this is where I want to get to the next note sheet here. All right. So, it says we can derive a formula for the nth term of an arithmetic sequence. Right, so I'm going to skip all this and then just remind you, because you did see this before in Honors Math 1. Right. Here is a general formula for any nth term. To find any term in an arithmetic sequence, you're going to take the first term, add to it this product of the term number minus 1 times the common difference. Okay, so here's a general formula to find any nth term. So to show you how to use this, we'll move it on to example 5. Given the first term is negative 2, the common difference is 4. We want to find the 40th term in the sequence. What's the 40th number? So again, instead of just adding 4 a bunch of times, we're going to use this formula. I want you guys to use this formula. So to find the 40th term, we're going to take the first term, which is negative 2, add to it the product of n minus 1, so 40 for the 40th term. Then we're putting n represents the term number, minus 1, times the common difference. So you plug that all in your calculator, do the math, and you get the 40th term is 154. I'll do the same thing here for example 6. We're trying to find the 100th term, so a sub 100, and representing the 100th term, we're going to take the first term plus the product of the the term number minus 1 times the common difference. Negative 272. Here you're given the pattern, you start the sequence, and we want to find the 80th term. Again, we're going to use this formula. A sub 80. The 80th term. So let's take the first term of the sequence, -1, plus, right, the term number that you're looking for, -1, times the common difference. So we're going from -1 to 2 to 5. So as you go from one number to the next, you have to add 3. So we're going to multiply by that common difference of 3. And so when you do that, you get 236. Now for these last two problems, it says, can you find a formula for the nth term of a sequence whose 4th term is 3 and whose 20th term is 35? So for this one, we're going to have to use the formula twice. So we're going to set up this system of equations, right? So we know the 4th term is 3. So 3 is how I'm starting. So you're going to get the term value equals a sub 1, the first term, 4 minus 1, and 4 is the 4th term. So this is about the 4th term here. So the 4th term value is 3 equals the a sub 1, so we don't know that, times 4 minus 1 times the common difference, which we do not know, so I'm going to put this d. And we're going to write another equation about the 20th term. Well, the 20th term value is 35, and that equals, again, the first term, which we don't know, plus, that's the 20th term, so we're doing 20 minus 1 times the common difference, which, again, we do not know, right? So again, this is all coming from the same sequence. So this a sub 1 and these d values should be the same. So assuming that, you notice that we set up here a system of equations, right? And again, the way we solve for systems is one way is by using the elimination method. So I'm going to go ahead and quickly do the math here. So we get 3 equals a sub 1 plus 3d. 35 equals a sub 1 plus 19d. Alright, so here again, it's a system of equations. So I'm going to use the elimination method. I'm going to multiply this top equation by a -1. That's going to be -3, negative a sub 1, negative 3d. Alright, I'm going to use the elimination method. So I'm going to add straight down. I'm going to eliminate the a sub 1. Those are going to go away. So now I'm left with 32 equals, and a sub 1s are gone, 16d. So now I solve for d, divide both sides by 16, and I get d is equal to 2. So there's my common difference. Alright, so now I need to find my first term. So again, just like we solve systems, I'm going to take my value of d, plug it in to here. So I'm going to solve for a sub 1, so 3 equals a sub 1 plus 3 times 2, plugging 2 in for d. Solve for a sub 1, I got a sub 1 is equal to -3, right? Because 3 times 2 is 6. Subtract 6 from both sides, I get a is equal to -3. So here's my formula. A sub n is equal to the first term, which I just found, plus n minus 1 times the common difference of 2. So there's my formula. Alright, and you can try this out with example number 9. I'm going to go ahead and give you the answer. So again, you're setting up a system using this formula for any nth term of the sequence. Okay, this was kind of messy here. So I'll give you the setup real quick. So again, here you're given the 5th term is 12, so 12 equals a sub 1 plus the 5th term minus 1 times d. Here we're given the 17th term is 16. So we get 16 is equal to a sub 1 plus 17 minus 1 times d. Okay, so when you solve that, and again we're looking for the 75th term, you should have found the 75th term to be 106/3. Alright, I'm out of time, so you guys have a great day. See you tomorrow.